Welcome to The Explainer. Today, we're looking at some seriously cool tech from NASA. It's all about bringing back supersonic passenger flight and how they're tackling the one huge problem that's kept these jets grounded for the last 50 years, the sonic boom.
So let's just start with a basic question. We've had the ability to fly faster than sound for decades, right? So why can't you hop on a plane and get from New York to Los Angeles in just a couple of hours? Why has this amazing speed been basically off limits over our cities and towns? Well, the answer comes down to one thing, the sonic boom. See, when a regular aircraft breaks the sound barrier, all the shock waves it creates kind of pile up and merge into one massive, thunder-like boom. It's a sound so disruptive that for over half a century, regulations have pretty much made supersonic travel an oceans-only thing.
And that's created what is basically a regulatory wall, a wall built entirely out of sound. It stifled innovation and really limited how fast we can connect our world. But what if, instead of trying to get around that wall, you could just solve the boom itself?
And that brings us to NASA's quiet quest. So let's meet the hero of our story, an experimental aircraft designed to do exactly that.
This right here is NASA's X-59. It is the first major piloted X-plane built in over 2 decades, and its mission is super specific. Make supersonic flight so quiet it could fly over your house and you might not even bother to look up.
So how in the world does it tame that boom? Well, the entire secret is literally baked right into its unique shape. You see, a conventional jet creates what's called an N wave. Basically, all its shock waves slam together and create that classic, startling boom. The X-59, though, has been engineered, every single inch of it, to keep those shock waves from ever merging. The whole idea is to transform that loud noise into a series of quiet, gentle thumps.
Probably the easiest way to picture this is with the boat wake analogy. Okay, think of a typical supersonic jet as a big, blunt speedboat just plowing through the air. It creates one single massive wake, right? That's your sonic boom. Now, picture a long, sleek canoe. It's designed to glide through the water, creating a series of small, barely noticeable ripples instead. That's the X-59.
And you can see that principle in action right here. The X-59's incredibly long, slender shape, we're talking nearly 100 feet, is precisely tailored to manage every single shockwave and keep them from ever piling up.
And notice the engine. Unlike on most jets, it's mounted on top of the plane. This is a really clever design choice that shields the ground from the engine noise, directing it up and away from people below.
It gets even wilder. The cockpit? There's no forward-facing window at all. To maintain that perfectly smooth, quiet shape, the pilot uses a high-tech camera and display system instead. I mean, every single element of this plane is designed to control airflow and sound.
The design goal here is for the X-59 to cruise at Mach 1.4. That's about 925 miles per hour. So yeah, it's comfortably faster than the speed of sound. And here's the key. It's designed to fly that fast while producing a sound on the ground of less than 75 perceived level decibels. To put that in perspective, that's about as quiet as a car door closing. Not a boom, just a gentle thump. But you know, building this incredible aircraft is really just the first step. Next, NASA has to prove that this amazing technology actually works in the real world. And that's where NASA's Quest mission comes in. It's a methodical, 3-phase plan. Phase 1 was all about building it and starting to fly it. Phase 2 is proving it's as quiet as the computers predicted. And Phase 3, which is the most critical part, is flying it over actual communities to see how people react. And Phase 1 already hit a massive milestone. After years and years of development, the X-59 took to the skies for its very first flight on October 28, 2025. After a flawless 67-minute flight, test pilot Niels Larsen stepped out of the cockpit. And just like that, the program officially went from years of ground testing to actual flight operations. It was a huge moment for the entire team.
This all leads up to Phase 3, and the mission's ultimate goal isn't just to fly a cool plane. It is to fly over communities, collect data from microphones on the ground, and then actually survey the residents and ask them, hey, what did you hear? And did it bother you?
Because if the Quest mission is a success, all of that data could unlock a brand new era of aviation.
That data is going to be handed directly to regulators like the FAA. It's designed to give them the hard proof they need to finally update that decades-old ban, to create a new rule that's based not on how fast a plane is going, but on how quiet it is.
And this really isn't just about an amazing piece of engineering. This is about changing how we travel, cutting flight times in half, and bringing the entire world that much closer together.
Thanks to the incredible technology packed inside the X-59, a future that was grounded by noise might finally be ready for takeoff. The question is, will the gentle thump of a quiet supersonic jet soon be a part of your travels? That's all for this explainer.